Good afternoon, or whenever it is that you're listening to this recording. This is a brief recap of what we did in class this last week. And this is for anyone who might have missed. A few of you missed class, so I wanted to cover at least a tiny bit of some of the material that might be a little bit harder for you to find online. We talked a lot about objects. We had a mind map that showed everything that you ever wanted to know about objects. And instead of covering that again in this lesson, what I would suggest you do is go to the Unity website, and I have placed links in Blackboard. I actually stuck them under reading materials, and so if you want to go over there and find them, you can. Here under videos, I recommend you watch the video on classes and all of the videos in the intermediate section. So just a quick look of what that looks like. The intermediate scripting section covers everything that we are currently talking about in class. So it starts off at properties. You should watch the classes video first, but then jump right into this. So properties, we did that. We don't really talk about the ternary operator. Statics, we haven't gotten to yet. Method overloading was a big topic that we talked about. Inheritance, polymorphism, member hiding, overriding. These are all things that we talked about in class and gave concrete examples on them. And then these other things that maybe we haven't seen yet are things that we're going to talk about in our next class and maybe the class following it. So this is really a good list of topics that you should cover as we start to move into more advanced coding, and then we're going to start jumping into Unity just as soon as we get all of that stuff installed in our classroom. So hopefully that will be very soon, and we can start working in Unity itself. But in the interim, it really helps you to learn how to do this in Visual Studio, and when you do that, you're going to learn more about how Unity works under the covers instead of just learning it by rote, and that's really one of my main objectives for the course. So given that you can watch all of this on your own and you don't need me to take you through it, the part of this week's class that really you're probably going to need a little bit more help with is the UML section. You have a UML assignment due this week. So that's what we're going to focus on in this little short video. You can go through the UML section of the mind map, but it's not too hard to hit all the high points. So the biggest ones are the things in white here. UML is to programmers what sheet music is to musicians. So UML is really just a set of diagrams. It stands for Unified Modeling Language, but it's not really a programming language. It's really a documentation standard, if you will. It allows you to create documents and, more specifically, diagrams that any trained programmer should be able to read and use that as a map to implement your code design. So you can create your code design in a non-code format, in a diagram format, and then hand that off, and it doesn't matter what language they're using or what tool they're using, they'll be able to use UML to implement what has been designed. So that's it in a nutshell. And what we did in class was we were going to focus on class diagrams and use case diagrams, and those were the things that we did in class. Your assignment really is to focus on class diagrams for a particular problem that we posed in class. And the software that we elected to use, it doesn't matter what you use to do your UML diagrams. You can use anything you want. You can draw it on a cocktail napkin and scan it for all I care. But it's useful for us to talk about something in class and use a tool. And I elected to use a tool called Dia, or maybe it's Dia, but I say Dia. This is a free tool that you can get, and I have added a link, and I put it in the labs section. So if you go to the labs section, you'll find a link to Dia, and there are two versions of it. There's the one that you can install on your computer at home, and then there's a portable version. So if you click the link, it will take you to the permanent, I'll call it the permanent version. You can put this on your computer at home or your laptop or what have you. It's open source software, it's completely free. Or if you want to use the portable version, the link for the portable version is here, and that's what I'm going to use. I have portable apps installed here on my system, and I can run, I think it's under graphics. And there it is, Dia Portable. And this is just a general purpose diagramming tool, which also happens to do UML. So the first thing that you're going to want to do is you're going to want to come over here and change whatever this default is, probably set to assorted by default. And let me see if I can zoom in on it. And you're going to want to change that to UML. And now that gives you a new set of tools to work with. So we've talked a little bit about objects. We'd actually, in class, we talked at great length about objects. And what we do in this case is we're designing objects, we're designing classes, but we're doing it without coding. So the advantage to this is you can get your structure down in a nice, convenient graphical format. A lot of people are visual thinkers, and it helps them to see everything laid out in a graphical format before you even start coding. And the other nice thing about this is you get to think of everything in advance, and you don't spend a lot of time trying to code something that ultimately you may not even need. So I'm going to start by creating a class. Now the problem that we presented in class is actually an assignment. So if I go to items I must turn in on time as part of my grade and go to programming challenges, we will see the modeling assignment, and it is our objective to create a Dungeons and Dragons style character. We want to model a character. And we went through part of this in class, and then it's of course your job to go through and finish it out. And for your assignment, I expect you to do your best. I don't expect it to be perfect because I'm assuming this is going to be, for many of you, your very first UML diagram. And of course, as your teacher, I want to teach you how to do it, so don't feel like it has to be 100% perfect. I always think that if a diagram can communicate well enough that a programmer can follow it, then it's probably a good diagram. So we're not that worried about following all the rules that are inherent in UML diagramming, and there are many of them. I'm really just more interested in, can you get the process down and think it through? Because if you are that interested in UML that you want to get really, really, really into it, you can go and take an object-oriented and analysis design course somewhere, maybe even here at Richland in the computer science department. I haven't checked to see whether that is amongst our offerings, but you could certainly take one at a four-year college. That is part of any CS or software engineering degree program. So if you're going on past your two-year degree, you're definitely going to run into this. So developing a class diagram in UML is actually really easy. You can do this in Dia, or again, you can just draw this, anything that supports drawing boxes software-wise, or of course, again, you can draw it on paper or a whiteboard. Of course, you can't turn in the whiteboard, so you're probably going to have to draw it on paper or use a tool like this one. It's really simple. It's really boxy, basically. So I'm just going to click this first one up here in the corner. This indicates that it's a class diagram. And once it's on the canvas, I'm going to double-click it, and this will allow me to work with it. So what I will do is I'll change the name of my class, and if I go back and look at my requirements, I know that I'm supposed to develop a character from Dungeons and Dragons. So I'm going to go through this fairly quickly. If you've never played Dungeons and Dragons before, there's a link to the original rule book, and I recommend that everybody read it because basically every game known to mankind is based on these rules. So in some part, if you have any knowledge of or any concept in your game of damage, if you have any concept of health, hit points, anything like that, all of these concepts come from the original Dungeons and Dragons game, which is, I guess, now at least 20 or 30 years old. So this is a very important piece of history, and I think it's important that you guys at least have some exposure to it if you've never played this game before. It isn't a computer game. It's played entirely on paper and pencil and with books, and it's a great deal of fun if you've never tried it. So check it out. The original rule books are linked here. And I think a lot of this, even if you've never played, if you've played any sort of role-playing game that has sort of a Hobbit, Tolkien-ish, dragons, any sort of a medieval mythological theme to it, this will probably be somewhat second nature to you. For like if you've played Baldur's Gate. Baldur's Gate the whole series is derived directly off of the Dungeons and Dragons rule set. Anything along that genre is going to be based in part or entirely on these concepts. So this is going to be my attempt at a first run at this assignment. You shouldn't take this as the absolute only right way to do this assignment. There are many ways, as you'll discover, to get the job done, and you may not even agree with the way that I'm designing this. Once you get into it, you may decide to design things a completely different way. My objective here is just to get you started, to get you thinking about it, and to show you how to use Dia if you want to use this tool. We're going to start off with a player class, and this is going to represent our player. And you'll notice it hasn't changed yet. As I type things into this properties window, I can click apply and then see the changes in the diagram itself. UML is all about making classes, and this tool is really geared towards C++ developers, so they have a slightly different vocabulary than what we use in C#. They have attributes and operations. We have properties and methods. Other than that, they're the same thing. It's just a semantics problem. So if I click on attributes, now I need to think up common things that would describe a player in Dungeons & Dragons. A player character, I guess I should call this. It would be more appropriate to call it a player character. So let's do that. As opposed to a player who might be the actual person who's playing. Okay, so every character has a name. So we'll start with that as a property. And we'll say that that is something that they all have. Now if you want to, and if it's really obvious, you can go ahead and define what type of data this is going to be. This is very obviously going to be a string. There's no two ways about it. So I might as well just go ahead and type that in there. If you don't know if it's going to be a complex type like an object that you make later, you can leave this blank. And the other thing that you can specify is what you think the starting value for this particular variable might be. And in this case, I'm not going to put anything here. It's just going to be empty. The last piece that's important for us right now are the comments section, and this is just for documenting more about what this attribute or this property is going to be. This is going to be the name of this is the name of the character. So if you want to call him Elric of, I don't remember this guy's name. Maybe you've heard of him, Elric of Melonbone, very famous. Maybe that's going to be his name. And so that's just an example of how it might be used. Now in Dungeons & Dragons, all characters have a default set of attributes. So let's do these basic ones, and I'm just going to put them in here fairly quickly. I'm going to put in strength, and I'm going to code this as an unsigned integer. Now you can do an integer, you could do a short integer. There's lots of things that you can do with this. I'm going to go with an unsigned integer because I know that the values have to be between 3 and 18. It can never be a negative number, and I have an advantage if I code it as an unsigned integer. The compiler isn't going to let me make a mistake and very obviously assign a negative number to it. So there's a little bit of advantage here, but if you want to use an integer here, it won't matter. It's all going to basically come out in the wash, so to speak, and since the range on integers and unsigned integers is so large, you're obviously also not going to run out of room. Okay, default value, I'm not going to assign one. This is going to be how strong the character is. And I'll go ahead and do the rest of them fairly quickly without much commentary. The next one is intelligence, which is basically how much or whether or not you can be a spellcaster, if I can spell it correctly. And the next one is wisdom, very important to clerics. If you want to be a cleric, your magic comes from a deity in the game, and so it is dependent on your level of wisdom. The higher your wisdom, the more spells and the more different kinds of spells you can cast as a cleric. The next one is dexterity. This is very important to thieves and also to fighters, but it's the chief deciding factor as to whether or not you can play a thief. You have to have a high dexterity. So this would be ability to use ranged weapons. And thieving skills. Next one is constitution. This determines how many hit points you get as you level up, so it's actually very important. And the last one is charisma. Oops. Which is how attractive you are, which seems strange to be in a Dungeons and Dragons game, but a lot of things happen with respect to social interactions. You're always trying to get people to help you, or get people to give you information, or talk to people in taverns and stores and things like that. As it happens in the game, if you have a high charisma, that basically means that you're really, really good with people, and they're more likely to help you or even give you discounts on equipment if you have a high charisma versus if you're ugly and mean, then you're not going to get those kinds of benefits from it. So as I mentioned before, all of these have a value between 3 and 18, and there's no UML way to express that. So I usually just put this in the comments. And that way we can apply. I just happen to be over the apply button. I didn't mean to say it that way. That means we can actually make this happen in the code. But I'll go ahead and click apply so we can see what our diagram looks like at this point. So you can see what it did. It puts the name of the property, so name, strength, intelligence, wisdom, etc., and it puts the type if you have specified it. And in this case, we specified all of the types. And then the other thing that it puts out here is a plus or a minus depending on which access modifier you've selected. There's a whole video on access modifiers that I mentioned earlier, so you can watch that if you're unsure how these things work. But essentially, you've got 4 of them. You've got public, private, protected, which are the same in C#, and then instead of implementation in C#, we call it internal. So this has to do with the concept of encapsulation and the concept of data hiding. So that's all in those videos, and we'll be covering it again and again and again because it's a very basic concept. So if you're not sure what these mean, certainly speak up in class, ask the question, and I'll answer it in class. All right, so in our UML diagram so far, we have the name at the top, the name of the class that is, and then we've got all of these properties. The line below that is going to be your methods. So we have a special method that appears on all classes, whether you want it or not, and that's called a constructor. The constructor is always named the same as the class. It does not have a return type. But it can take parameters. So I'm just going to leave that like that because it's going to be a constructor, and we're probably going to want that. And I'll click apply. So there it is. And now you can see that our methods are appearing below this second line. So the properties are at the top, the methods are beneath that. And that's pretty much all there is to a class diagram. So let's take it a little bit farther. There are a few more attributes that I wanted to put on here, namely hit points and level. And maybe experience points. And gold, how much gold you have. We decided in class that we would make this easy and just make it an integer. Actually, let's make that a regular integer in case you want to go into debt. The Dungeons & Dragons rule set has denominations. You can do copper pieces, silver pieces, platinum pieces, electrum pieces, gold pieces, and there's a conversion rate between each of them. That's a little more detail that I'm interested in. So that's all fine. So now we have all of our attributes pretty much on here. And that's our very first class, so that's pretty good. Now if we go back to our assignment, if you can come up with, by the way, again, if you can come up with other stuff that you want to put in here, that's fine. If you can think of other methods that you want to put in here, that's also fine. Really, we're just trying to get this started, so the next part that I want to look at is inheritance. In class, we talked about, actually before we get into inheritance, let's talk about the race. So we have a number of races that your character can be. And in class, we talked about a concept called an enum, or an enum, depending on how you want to say it. Again, there's a linked video on enumerations, so you can check that out. So if we want to make an enumeration, it's going to be a very small class. And what do we want to call it? Races. And I'll probably just put in the comment that this is an enumeration, because there really isn't an enumeration diagram type in UML, but I wanted to put it in there just so we can kind of be thinking about it. So if we do this, an enumeration, really all it does is it allows you to have an integer type, but without having to remember what the integers are. So if you would envision our race being, let's go back and look at our list, human, elf, dwarf, and gnome, you could say 0 is human, elf is 1, dwarf is 2, gnome is 3, etc. The problem with that is that you now have to remember that elf is 1 and dwarf is 2 and gnome is 3, and that might be kind of hard. So what you wind up doing is you create an enumeration, and now you can actually have those numbers correspond with names that makes them easier to remember. The other thing that that does for you is it gives you a new type. So when we go into our player character, we can now add an attribute called race, which is of type race. That might be a little confusing. Maybe we can make this be called character race, just so that we're clear on which one is which. And we click apply. And now we've got a race. Now this is our type over here, if you want to diagram it as such. And now we have this character race over here. We're actually going to look for a way to link these things together so that you can tell that this character, or this player character, and the type that it involves this class right here. But this is a little bit easier to see when we do the next part, which is their profession. So what they can actually do. So let's take a look at how to do that. And there's several ways you can do this. So I'm just going to pick one and run with it. I'm going to use thief as the example because frankly that one to me is the most interesting. It has the most stuff on it. So that's the one I'm going to pick. But what I could do is make a class for each of those. So I'll make one for fighter. And I'll make one for, I'm not going to make one for all of them, just so you get the idea where the list is coming from. Fighter, I'll go ahead and do thief. IEF, I think that's right. Good thing this is an English class. Okay. So we talked about inheritance in class, and if you don't remember inheritance or you weren't here or you don't know what that is, again, go watch the Unity video and it will explain what inheritance is. But in a nutshell, it means that you can take a class like player character and make another class out of it, which has specific things in it that are unique to thief, but also share characteristics of the superclass or the parent class. In this case, we're going to say that a thief is a player character, and that's one of the most important things that you can remember about inheritance. The term is a. I think I can put a little text notation on here. This isn't part of UML. This is just me putting something in here to remind you. So inheritance, think of is a. So we can say that a thief is a player character and a fighter is a player character. So a thief has some attributes that other things don't have. So fighter has all of these attributes plus an extra one. There's actually one. Let's just do this one real quick. They have an attribute called encumbrance, if I remember correctly. It's an unsigned integer. Oops. UINT, and it can be from 0 to 100. So if you have a strength of 18, actually it's a little deeper than this. If the player's strength is 18, then they get an encumbrance value from 0 to 100. And you'll see this expressed as a fighter having a strength of 18/25 or 18/67, some number between 0 and 100. And that's what makes them a little bit different from the other players. This means that you can carry more, especially with respect to armor. So it really affects what armor you can wear and how, can you carry a halberd while wearing plate mail? And can you figure out a way to wield a shield with all of that? Probably not, but you get the idea. Plate mail is very heavy, chain mail is lighter, leather mail, not a problem. The better your encumbrance is, and plus half the time the fighters wind up carrying the sack of loot because they're usually the strongest. So this determines what the fighter can carry, and they can carry quite a bit more than everybody else can. Thieves, on the other hand, have lots of attributes that are very unique to thieves. So thieves can do things like hide in shadows, and these are expressed as percentages. So I'll stick with my uint, and you'll just have to remember that they're percentage. Well, I'll put one in for the first one. So it's a percentage from 0 to 100. The list of these attributes I made over here, so they can hide in shadows, pick locks, spot traps. They can backstab, so they get like double or triple damage depending on their level. And what else? Pickpocket. I don't think I put that one in there. Okay, I didn't bother to put uint on all of them because this is running longer than I hoped it would. Okay, so now we have a fighter and a thief, and both of these are going to be subclasses or child classes of player character. We indicate this on a UML document with one of these arrows. So you can see if you roll over them what they are. The one we're looking for is generalization class inheritance. So I'm going to click on this, and I'm going to draw an arrow like this, and then I'll go ahead and do that for the other one as well. And there we go. The important thing to remember is that the arrow points to the general class, not the specific one. So a lot of people will get it backwards and have the arrow going from player character to thief and the arrow pointing down at the specific class, and that's not right. Okay, so what this means is that this class is the parent class. These classes are child or children classes. Another way to say it is this is a superclass and this is a subclass. All of those terms basically mean the same thing, but they really are summed up by the term is a. Thief is a player character. Fighter is a player character. So that's inheritance, and that's how you diagram inheritance. Let's go back to race for a minute. This is a slightly different thing. Instead of is a, this is going to be something called composition. And there's a different diagram for that. It's this little diamond one right here. And we draw it like that. And the term for this one, instead of is a, we're going to say has a. So a player character has a race, and that's what the diamond indicates. And the other thing that you can do with these is the concept of multiplicity. Well, let's go do multiplicity very quickly. This is really getting ahead, but I think you can handle it. Let's say we have a class called inventory item. And inventory item might have a few properties on it, such as, let me zoom in a little bit, make sure everybody can see. So it'll have a weight. It will have gold piece value, since almost everything can be purchased. And that's probably good enough for now. This is going to be a very general class. And now that we have an inventory item, we can specify on our class that our player character has an inventory. Which is going to be a collection. We haven't talked about collections yet, so I'm just going to leave that blank. But consider that, well, I'll go ahead and put it in there so that we can remember what it is. It's going to be a collection. Don't worry about what the I is. It's an interface. We'll talk about that later. But this is going to have many things in it. Okay, so we've got an inventory collection, which is a list, a group of things that are of type inventory item. Whoops. I'll get it out here in a minute. Here we go. So you can say that the player character has a or an inventory item in this case. And again, we're going to mark this way. But this time we're going to have an additional little property that we're going to set on this called multiplicity. So multiplicity can tell you that you can have multiple things. And I usually put it on the B side. Oops, here it is, multiplicity. So there's multiplicity right here. I'm going to say 1, 2, and I usually copy the infinity symbol in here because that's the right way to do it, but I don't have that handy, so I'm just going to write INF for infinity for short here, which will be good enough for us. And what this means, when I click on it, you can see that it adds it here. What this is telling the programmer is that inventory item is going to appear in inventory, and this isn't really clear, so let's make this a little clearer. I just said it was an I collection. I didn't say a collection of what, so let's fix that. If I put in here inventory item like that, now we have the ability to tell what the real relationship is here. That's better. Okay, so now we can see that I have an inventory. It's a collection of some sort of inventory items, and there can be one or infinite. So we can have from 1 to an infinite number of things. Actually, we could probably make this 0 to infinity because it's possible at the very beginning of the game that they won't have anything in their inventory. So we'll say 0 to infinity. However, they can only have one race, right? You can only be one race. So we can make this 1 to 1. And now the programmer knows that there's a 1-to-1 relationship here, and that just reinforces the fact that we didn't put any sort of collection on there as a type. Again, you don't have to put the type, and we don't know that race really is anything other than what we show here. So the multiplicity is just another clue, or another cue rather, that tells you whether or not there are multiple items that can go in that particular attribute. So player character has an inventory which can consist of many inventory items. So if you were to take this to its logical conclusion, that would be a great assignment to turn in. From here, you can start thinking about what's going to happen next, and it's going to get pretty complicated. You can branch off of inventory from here and start talking about what kinds of inventory items are there. For example, you could do a weapon, which would be a type of inventory item. And from there, you have to start thinking about, see if I can hit it one more time. Zoom out to be easier. What kind of weapon it is. Is it a ranged weapon, which has different properties than say a two-handed weapon? Okay, so now we've got this inheritance chain that's going to go inventory item is a type of weapon, ranged weapon is a two-handed weapon, is it a single-handed weapon, is it a blunt weapon? This could get really, really complicated. So as we move forward, we're going to start talking about ways to reduce this complexity, because anytime that you have 3 or 4 nested classes, it's starting to get too complicated, and there probably are better ways to do this. So you don't have to take it this far, but I just want you to start thinking along these lines. And that is probably, like I said, you need to go through and make sure that we've headed down that path. I didn't do anything with the alignments, so I'm sure you'll think of a way to do that. And we've only just really scratched the surface on how to do this. So if you want to try to come up with an inventory, then you're certainly welcome to try that. And I encourage you to try it. If you get it wrong, it's not that big a deal. We will work on correcting it as we move forward. But give it a try and see what you think and see what you come up with. And we'll just improve on it as we move forward. So that's it. That's, in a nutshell, what you missed last week if you didn't come. Again, there was a whole bunch of lecture material on object-oriented concepts, hopefully. This is something that's not new to many of you. And really, we just want to focus on this UML stuff. So that's it. I hope that helps. If you have any questions, drop me a note in email, and I will certainly answer it fairly quickly. And I will otherwise see you in class.